Today we will discuss about the power series for logarithmic function using e power by x or e was simply and if we use e in logarithmic, so we will use the notation of e using ln, because ln was equal to a log b, for example. This is the b. So if the basis value was using Euler number, so you only mention or write as ln b only. And today we will continue to the power series for e power by x. This is the function of the power series for a power by x equal to 1 plus x, so similar with the variable, plus x squared per 2 factorial plus x power by 3 per 3 factorial and etc. And this is we call as a series for e power by x. For example, if x was equal to 1, means that a power by 1, so we can write it in the same function. First plus x and x substitute with 1 and plus x squared, so we substitute x with 1 squared per 2 factorial plus 1 power by 3 per 3 factorial and etc. You can write until at least 5 series. 1, 2, 3, 4, 5. So 5 series it's enough. But maybe this is too simple. So please add more until 6 or 7. It's okay. After that, you calculate for its function. You get this function number, and then so for e divide power by 1 will equal to 2.71828, and this number was similar with the value if you check with your calculator, almost similar. Yeah. 2.71828, and if you only using 4 digits, so you can write 2.7183. It's okay. And then also with the same way, you can also calculate for e power by 0.05, and you can also using the same way for the basic function for the power series, and then you will get a power by 0.05 will equal with this function, and the a powered by 0.05 will be equal to 1.051 n and etc. Usually maximum using 4 digits is okay. 1, 2, 3, 4. So 2 and 7, if you can combine, become 3. Up become 3. And this is the power series of Euler function. And then the other example, if we use x equal to minus x, so we can also using the same functions, a powered by minus x, so you substitute all x value with minus x, so you will get this function. So this is the basic function of a powered by minus x. And also with the same manner, we can get if you have a constant, for example a constanta multiplied by a powered by kx, k also sum of constanta, and x was variable, so you can write the basic function of the a power multiplied by a. You can give the big parenthesis group for the basic function of a over kx. Also for x you can substitute with all kx, kx squared, kx powered by 3 and etc. For example 5 multiplied by a powered by 2x. So if put 5 in front of and give a big parenthesis, then write the basic function of a power and substitute all x with 2x, and then you will get the basic function. If you want, so please multiply all of 5 with 1 by 1 with all the cells, so you will get the basic function. For example, determine the value of 5 multiplied by a powered by 0.5. 0.5, we already have the value a powered by 0.5. So this is the basic function, or this one. This is the basic function. Then you can multiply by 5, because the result of a powered by 0.5 was 1.64872. You can simply multiply with 5, so you can get the result for 5 multiplied by a power series. Then we continue to problem 15. You can see that the function a power multiplied by function the function was x squared minus 1. You know that the basic function of a power series was mentioned like the previous function, like this. So you just simply multiply by the second function with x squared minus 1. So please multiply 1 by 1. After you get the result, if there is a probability to make the formulation more simple, for example, x squared plus x power by 3, I think we cannot add it because the power was different. But for this, maybe if you add more, maybe for factorial, you can simply with this one, or also with this one. So, or you can leave the rest equation in the original function. It's like this. So for this is multiplied by x squared, and the second one was multiplied by minus 1. And then you can transform this equation. You can collect or grouping with the same value for the power. For example, x squared with x squared, x powered by 3 with x powered by 3, and also the others you can grouping in one parenthesis group. So you will get the result. So this is the power result. I think this solution is not difficult for you, but you need to carefully, because you must calculate many numbers. For example, this one and this one. I think it's easy for you, but maybe the big problem is you can grouping or you can writing carefully. You must carefully to calculate all the equations because you facing with so many equations. But I think it's easy. Okay, we continue. Sorry, do you have any question for A power series? Did you understand? Okay. Is there any question? Not yet? Okay, we continue. Let's go to, I think we skip this exercise 19. We go to graphic of exponential function. To make a graphic, maybe it's easy if you using some spreadsheet application like Microsoft Excel or using MATLAB or Minitab, it's easy. But if you using manually, it means that you have drawing books. So you must put all the number for the ordinate number, so you can make the good graphic. For example, if you want to make the graphic of exponential function, for example, for value a power by x and a power by minus x, you must put several value of x. For example, for x minus 3, please put the value of a power by x for minus 3. And also for a power by minus x, for x minus 3, you can put the value. So if you already provide some several value for x, you will also get several result for its function. After that, all of this number and all of this basic x value you can put into a graphic. So the axis of x you can put for the horizontal axis, and the value for a power by x and a power by minus x you can put in a vertical axis, and put the every result. For example, minus 3 for a power x for this one, but a power minus x was this one. So put all the dot correspondingly with horizontal axis and vertical axis. After that, you can connect all the dot with a single line. So the result, you will have the curve of the function y equal to a power by x for this one. And for the second curve, you can get the curve for function y equal to a minus x. If you see all the curve was identically similar each other, but it's like a mirroring. For example, like this was mirroring with the vertical axis, so you will get the other mirror. Okay. So we can assume that the a power by x, if you change the value of x by minus, so you will get the result was in the mirroring condition with the original function. This is for a graphic for a power series. And also, if you have the other function, for example, the function was y equal to 2e power by 0.3 x. So with the same way, because minus x minus 0.3 to a power by 0.3, you already a power by x, you already have the value. So for the other function, you can simply multiply with 2 and find the value of a powered by 0.3x, just like this. Then we will have the graphic. So I think the equation was simple, but to solve the equation you need long process. You need a long process because, for example, for x minus 0 minus 3, for example, you must calculate one by one like this. Like this. So only for one value, for example, a powered by 0.1, you will get this value. So this is for only one x value. If you have several x values, so you must replicate the same step but with different x values. So maybe the equation was simple. Please find the value, or please make the graph of a powered by x for graphic. But to get the graphic, you must calculate one by one. If you have, for example, 5x value, you must calculate 5 times like this. So the equation was simple, but the process takes time. Because for get the result of this one, you must doing the basic power series. This is 1, 2, 3, 4, 5, 6, 7 x value. So you must repeat 7 times to drawing this function. But now, because the technology was quite high, you can use your laptop. You can open your spreadsheet application like MS Excel. If you already know the equation, you can make some equation in Excel. Then if you have so many value, I think you will get any trouble. You will not get any trouble if you use Excel or any kind of spreadsheet. But if you doing manually by writing and calculate one by one, maybe it takes time. I believe all of you can using MS Excel. Did you use your? Can you operate MS Excel?
Well, only the basic.
Only basic.
Yeah.
Okay. So this is a good time for you to improve your Excel basic, especially because we are studying engineering faculty. So many times you will need spreadsheet application to solve your calculation. So it's time. It is a good time for you to improve our learning using Microsoft Excel. maybe previously maybe you have to buy series was take time. So maybe I will skip the process and just jump to the result. But please make sure that you already know how to get the result. This is the most important. Okay, we continue to the next equation for problem 17. Plot a graph of y equal to 1/3 multiplied by a power by minus 2x and offer the range between x equal to minus 1.5 to 1.5. So this is the range. You can get the increment for 0.5. So if you start with minus 1.5, so you can get increment 0.5. So the next is minus 1, the next is minus 0.5, the next is 0, and the range was between minus 1.5 and 1.5. So you will get the 1, 2, 3, 4, 5, 6, 7 value for x. And using the same way for the basic power series, you can get for all the result for a minus 2x and 1/3 a power by minus 2x. After that, you can give on the dot and connect it on the dot with a single line, and you will get the graphic of y equal to 1/3 multiplied by a power by minus 2x. I think it's easy to see this graphic, but the process takes many time.
Yeah, but how do we know that the increment is 0.5?
Yeah. If in the question there did not mention about the increment, you can choose as you like. So in this question, they didn't mention about the incremental. So please choose your convenient incremental. So maybe the convenience incremental is 0.1. If you choose, for example, 0.3, maybe the number is difficult to get, but it's up to you. Or maybe you use small incremental, 0.1, between minus 1.5 until 1.5 using 0.1. So you will get so many value. Also, you will get so many dots. You will get so many dots. But I think if you make this manually, it's good for you because you will easy to connect it all the line, become the smooth line. If you have so many dots, it will help you to connect all the dots with a smooth line. But if you only have a few dots, for example, only 4 or 3, so maybe to connect it all the line, become single line, sometimes it's not quite good in a shape of the curve. And for the power series like this, in an industry real case, usually the A power series or A powered by function of X in real case in industry usually was modeled for the reliability maintenance. So the basic equation for reliability in X usually modeled by the A power series. For example, A minus 1.5x or something else. And this is the basic function of the reliability in maintenance. For example, if you have laptop, if you buy new laptop, so the reliability was 100% because you buy a new one. After that, you use every day, and the reliability will be decreased. This is time, and this is the reliability. This is 100. This is 0. 50%. For the first time, so this curve was the reliability curve. For example, if the basic function was A powered by minus 1.5x, for example, or any kind. So in the real case in industrial, usually A power series was using for maintenance reliability. For all the machine. For example, if in one company there is some series or group of many equipment. For example, in oil and gas company, because now oil and gas company was fired. So in oil and gas company there are so many equipment. For example, in an upstream side for drilling, they use many pumps. They also use compressor, heat exchanger, turbine, motor, combustion, and many type of. All the equipment will need the calculation of the maintenance reliability. For the first time, buying new, so the reliability will be 900. After 90, reliability will be decreased. Will be initial decreased performance until breakdown. In reliability, breakdown was not at 0 but at 70.7. Why? Because the A was equal to 1. It means that this is the broken part was happened at the same time, at the same t. So A powered by minus 1 will be equal to 0.367 and etc. or equal to 37%. So this is the breakdown. or the equipment was fall, simply fall or broken. So if you know the basic function of the decreased performance of the equipment, so you can predict when you have to repair the equipment. You know that the equipment will be fall in 36.7. For example, if this is 1000 hours. So before 1000 hours, you have to give a good maintenance for this equipment. You can predict. For example, oh, I will give the maintenance in 50% reliability. So you can get the time. For example, if the time is 650 hours. So before the equipment breakdown, you will doing the preventive action. For example, to change some parts, to give extra lubrication, to setting the position. So the breakdown was not happen because you give the good preventive action. After you give the good preventive action, so the reliability will come back into 100 again. Then continue again like this, and give the maintenance activity, then up again, then continue. So the company will didn't have any breakdown case for equipment, because sometimes for high risk equipment was forbidden. For example, storage tank. Do you know storage tank? A big storage usually keep the liquid or sometimes gas inside the storage. If the storage was filled by the vapor gas or some liquid with easy to burn, sometimes storage have some limits at the circumstance of the wall, because some case, the most case happen in the industry for storage tank was caused by corrosion. Do you know corrosion? Yeah. Because storage tank was made by metal, and every day was facing the environment with a high oxygen, sometimes rainy, sometimes sunny, every day like this. So at the wall there will be so many oxygen, and it will use some oxidation reaction causing corrosion. When the corrosion happens, so the thickness of the wall become thicker. Year by year, the thickness of the wall become thicker. After several years, so the remaining thickness of the wall of the storage tank will be very thin. If you use filling the tank with the pressure, vapor gas or liquid, so the thinner wall will be broken. Maybe if you store it with water, maybe the risk is low, maybe. But if you fill the storage tank with the gasoline, and the gasoline has some vapor gas, so the vapor gas was easy to blow up, especially if there is small fire. And several months ago, this kind of accident was happened in Jakarta. Did you remember the Plumpang accident. Did you remember? Maybe you read the newspaper last year. There's also some storage, gasoline storage tank leakage, and there is some big explosive fire last year because the some leakage, and the leakage was some gas was go out, and because this is the easy burn gas, and the near of the storage station was the surrounding was some village, some housing near, and sometimes they cooking or just smoking or something else, and the gasoline vapor was coming near the village because the storage became, and then a big fire was happened in Rumpak and Jakarta. So if you can predict the corrosion rate using the reliability function, you can using a preventive action, for example checking the thickness of the storage tank wall periodically, because you know that after several years the thickness of the wall will be thicker. This is the natural process. We cannot avoid about the corrosion. For example, this chair. This chair was made by, this frame was made by metal and coating with some chrome. Why they coating the basic metal? Because they want to prevent the corrosion. If this chair didn't coating by chrome or any other protective layer, maybe after you buy 1 week, this frame, if they not coating with the chromium, maybe only 1 week, the surface of the frame will full of the corrosion. Especially if you put in a high humid room, especially maybe 1 week, you can see the color of the metal. A power series was in maintenance reliability for every equipment, including all of your stuff. All the stuff will be using the same manner. Your car, your motorcycle, and any kind of equipment you have in your house, your home, all will need maintenance reliability to prevent the risk when they are broken. Maybe for the low risk, it's okay if they are broken. For example, lighting. Company sometimes didn't prevent the lighting before they broke. They just simply wait until the light was off or the light was shadow. So they just simply change, because if the light was broken, the risk, maybe there is no risk. It's okay for the component with a low risk, but for the component with a high risk, if there is some broken, so we have to avoid the broken component, especially in industry. maybe the risk was not get some trouble to human. Sometimes if some equipment broken, maybe human it's okay. No need some injury, no need some fatality. But the production flow was stopped. They cannot produce the things or goods, and they have the loss production profit. If the breakdown takes very long time, so the loss of production profit will be so big. Yeah. That's why we have to avoid the equipment breakdown in industry. Okay, let's go to continue. For problem 18, this is the use of the power series in electrical component. The decay of voltage V volts across a capacitor. Capacitor is one of the electrical component. Inside, I think almost all the electrical device will using capacitor. Laptop, remote control, mouse, handphone will be used capacitor, maybe in a small part. And the capacitor at time t second is given by the equation V. V means the voltage. The voltage of the capacitor was equal to 250 multiplied by A power series with the function minus 3 per minus t, minus t per 3. So draw a graph showing the natural decay curve over the first 6 seconds from the graph. Find the voltage after 3.4 seconds for A, and B, the time when the voltage is 150 volt. It means that at the beginning, when the time was 0, it means that this is the new capacitor, so the time will 0. So when the time was A power by 0 will equal with 1. So the initial voltage will be 250 voltage. This is the initial voltage when you put the new capacitor. But after the capacitor using many times, so the voltage will be changed following this equation. And this is, you have to find what the decay curve over the first 6 seconds and the voltage after 3.4 seconds, and when time when the voltage 150 volt. So it's from 250 become 150. First, you have to make the table of all time and calculate all the value for A power by minus 3 per 3, and this is the result. For initial, the voltage is 250. This is in second. First second drop from 250 to 179 until so on. 3, 4, 5, 6. Then you can make the graphic. This is the graphic. So after you get the graphic, you can answer the question. Sorry. Where is the question? This is the question. Curve the first 6 seconds. This is the curve for the first 6 seconds, from 0 until 6 seconds. This is the curve. And then for A question, the voltage after 3.4. Because this is the time, so because the increment was 1, 2, 3, 4, 5, 6, so 3.5 will be raised from 3 to 4. So maybe this is the place for 3.4. So you can get the vertical line until contact with the curve. Then you can draw a horizontal line to the vertical axis. Then in the vertical axis you will get how many voltages. So we can see that after 3.4 times 3.4 seconds, so the voltage will equal to 80 volts. So this is the answer of A. And B, the time when voltage is 150. This is voltage 150. So you draw the horizontal line until contact with the curve. After that, you draw a vertical line. So you will get the time for 150 volts. The time was equal to approximately 1.5 seconds. So if you know the equation of this curve, you can predict all the value you want to know. If you know the equation. Same like in maintenance reliability. If you get the reliability function of the equipment, every equipment will have different equation. But after you calculate by data, you will get the basic equation for reliability of equipment. So if you get this function, you can easy to predict all the case will be happen. But this is for the scientific approach. This is all we do is how to predict the next case, because we don't know in the future what case will be happen into some equipment. So as a human, we can only predict by using scientific approach. But maybe the gods have another plans. We don't know. But for the scientific approach, we can predict when the equipment will break down or fall, when the equipment will start to decrease the performance using the equation. So it means that we study mathematics like today. Maybe we can assume that we also study about how the gods plan. But we can only assume and predict. And the prediction of human was very low, very poor. So this time we study mathematics, we study about God's plan. Because the ability of human was limited. Okay, then we continue to Napierian logarithms. Napierian logarithms. The definition of Napier's logarithms was logarithmic having a base of called hyperbolic shape curve. Napierian, or simply we call as natural logarithmic. Natural logarithmic is written by log A. It means that using log A, small a, x was also equal with a log x, and also equal with ln x. So if the basis number was Euler number, so you can change to ln function. For example, using of 4-figure tables, we also get some relationship. Log y, ln y, because there is some Euler. Ln y was equal to 2.3 log 10 y, and using the basic calculator you can get some information. For example, for ln 4.692 you can get this number. And then for ln e over x was equal to x, because ln, this is the basic value, was e powered by, I don't know, will result e point x. Remember this one, yeah. It is equal to a log b equal to c. You can transform into exponential function. This is the logarithmic function. Become a powered by c equal to b. So for this one, a log a pangkat x So will be equal by x, because a we don't know equal to a power by x. So the question mark will be x. So this one, a log a power x equal by x. So how to get this result? Please remember this basic logarithmic function. So of course with like this, for example, ln e 3x equal to ln x. So we can simply take 3x equal to ln x. Then x equal to 1/3 multiplied by ln x. And this is the result of x, 0.6931. So please remember this basic condition, basic function for ln power. Equation with the power series. Another example of the tension in belts. Tension in belts usually using in some moving mechanism. For example, in masonry mechanism, if you have some automatic motorcycle, all the drive gear for the automatic motorcycle was using belt, and also maybe almost all automobile also using belt to moving all the mechanism in the engine using belt. So the tension of belt was showing with this equation. The other example is Newton's law of cooling. This is in physics phenomena. The other is biological growth. For example, the growth of amoeba or bacteria, and many other example of the using of power in series. Almost of the case using a function, a power series function, including this also for the equipment reliability. Okay. I think this is a good book. I have the A books. Then I will give to you this mathematics A book. The title of this book is Higher Engineering Mathematics by John Byrne. I think this is a good book. Later I will check the size. Is maybe if size is very big. Maybe send to by WhatsApp. Maybe it's difficult. But I don't. I will try. I will try. I will give to you. Okay. Maybe time is over. So next week we will continue our